With spaceR, we present design and implementation of a resistive force sensor based on a spaceR fabric knit. In a spaceR fabric structure, stiff nylon filaments press two knit faces apart, which can provide a soft and appealing haptic property that is similar to foams. In this work, we introduce a sensor that adds the capability of continuous resistive pressure sensing to spaceR fabrics. Analog to a printed FSR sensor, we combine several materials like conductive and resistive yarns. We utilize the so-called interface effect by adding resistive yarn to the nylon filler. The electrical resistance drops whenever the filler is compressed. Our sensor is created in a single manufacturing step by using a regular industrial-grade 2-bed weft knitting machine and does not require any post-processing to be operational. The result is highly sensitive to pressure and has a comfortable haptic appeal. We compared different implementations by varying manufacturing parameters and evaluated their performance using a custom-built testing machine. For most variations, we found striking conformance between pressure and sensor reading. For more details, please refer to the paper. Furthermore, we present a design space that highlights design opportunities. We implemented several variations and experimented with parameters of size, thickness, shape, cross-section profile, and firmness. We explored their respective potential and present our findings. We discussed the influence between those attributes and how tuning of manufacturing parameters can help in designing them beforehand, for example, the result's cross-section profile. Finally, we demonstrated the functionality of our variations and show potential use case scenarios. For a dual-button controller, we use temporal data to implement mode switching, for example, for controlling the shutter on a window, where firm input controls motion and soft input controls tilting. We demonstrate a rocker button that provides intuitive up-down control by natural tilting gestures, for example, for scrolling on a web page. We implemented a 4-way analog controller, providing an input modality similar to a thumbstick, which can be used for continuous navigation input or controlling a spaceship. Finally, we created an experimental squeezer controller. In our paper, we present essential manufacturing details, discuss our implementation pipeline, and reflect on our findings regarding limitations and potential, as well as promising directions for future work.